Hey everybody, Mike here. Welcome to Lab. We're going to learn a little more about the gas valve right now. So the gas valve is a pretty important part. I think we would all agree it's function and it's also safety. So there's a safety feature that this does. So it does two things. It obviously opens and closes our gas flow. So the gas flow comes in over here, and then it comes out over here. And so we have about 7 inches of water column pressure coming in. There's not only a shutoff valve in here that opens and closes on a call for heat or when it gets to that point in the sequence of operation, but there's also a diaphragm in here that regulates the flow. So it's called a combination gas valve. It's positive shutoff, but it also regulates the flow. And so inside this little part, there's a little diaphragm. And I took the diaphragm out of this, but it's just basically a piece of rubber. And then right here, it modulates the flow. And so if you think about driving down the road in your car or your F-150 or whatever it is that you drive, you never hold the gas pedal perfectly steady. You're always modulating. The road changes, there's different things. It would be impossible to set your foot feed always the same. And likewise the steering wheel, you're always making minute little adjustments with your steering wheel, whether even on a straight flat road, whether you realize it or not, you're always making little adjustments. And so that's what our diaphragm pushes on this, pushes against that spring. And this is what's regulating the flow through that hole, is this just a plastic valve basically, and it's monitoring the manifold pressure and it's making adjustments accordingly. So another thing we already talked about, there's a coil in here which has a lot of little wraps of copper. And inside there's an iron core. And so when our copper coil is energized, it draws up and it opens a valve inside of here, which allows flow into our manifold, which goes up to our spuds, which goes through our orifices, which goes into our burners. There's fire, and then that fire goes into our heat exchanger and eventually comes out draft inducer and goes up the exhaust. So I'm going to show you a simple diagnostic. So there's 3 wires going to this. This is a 2-stage gas valve. So what do I mean by 2-stage? It means on a really cold day, there's more of a demand for heat. And if our thermostat drops below like 2 or 3 degrees, it'll send a signal to our control board and it'll say, hey, we need more heat. So it'll run at full fire or high fire. And then as it gets closer to its set point, the thermostat set point, if it's within 1 degree of set point, it'll kick down and it'll run at a lower speed, at a lower firing rate. So it'll run on high fire if it's a big differential between our set point and our actual room temperature. And then as we get closer in temperature, it'll kick down to low fire. So there's 2 coils in here, 2 valves, one's a low fire and one's high fire. So the middle, the blue, is our common wire. It's common to 2 coils. And so I can put either lead, doesn't really matter, but I can put a lead on my middle one. And I can put it right there. Get a close up. And I'm reading 18.58 mega ohms. So if you look right in there, there's an M. That means mega ohms. So I can leave that in the middle. It's in the middle, and I'm measuring the resistance of those coils where those copper wraps are. That's what I'm measuring, is the resistance. So the other one is 23. 23 megohms. See the big M? That's mega. So that coil is good. I have good continuity. That's about where it should be. I can show you another one. This one's not so good. So if I put a lead in the middle, and I put one there, it's reading open lead. So that means somewhere in there, in that circuit, there's a break in my windings. And so I'll check the other way. I can check from there to there. And once again, it's reading open lead. So that's an infinite resistance. It means it's infinitely resistant. It's no different than just having my leads like this. Okay? There's basically an opening in my circuit. So my path is somewhere in here is broken. And I'll show you what it looks like inside. I've made this so it comes apart easy. And there's my two coils. There's a big coil and a little coil. And that's the same as the one that we just read. So my common, the middle, try to do this so you can see it. So where my plug wires go, the middle one is common to both of these. It's like the common wire on both of these. Okay? And then this from here to here is reading the resistance of this coil. And when I measure from common to here, I'm reading the resistance of this other coil. And remember how the one was about 18 and I think the other one was 20 something, 24? That's the difference between a little coil and a big coil. So this physically, this one is bigger. Okay? Another thing that could happen is there could be a short. And basically, if you envision inside, if my coil wires break and they touch each other, you will have no resistance. It'll be just like touching your two leads together. It'll be like no resistance at all. So it'll read continuity.